Hey everyone, Math 103, we're working on section 3.1 today, Introduction to Equations. I'd like you all to start on the warm-up. Start off by naming the parts of this. I'm going to be referring to these terms quite a bit. It's going to be essential to know what the different parts of an expression like this are. So I'm sure you all are familiar with exponents. And the x is the base of the exponential expression. That's the thing we're going to multiply repeatedly. The exponent tells us how many times the x would appear in the multiplication. And then for this number out front, this is called the coefficient. Number 2, are common denominators required for multiplying fractions? No, I see this mistake all the time. People trying to get a common denominator when multiplying fractions, and it ends up being a big mess. So you do not need it. We need it with addition and subtraction because we can only add or subtract things that are the same. Can't add together things that are different. So that common denominator, that makes the things alike so that they can be added and subtracted. Number 3, we're multiplying some fractions here. We're just going to multiply straight across. 2 times 8 is a 16. 3 times 5 is 15. So 16/15. Now the next one, I see a lot of mistakes with these as well. Think of the 4 as being just 4 over 1. Any number, you can just write it over 1. And now we're going to multiply just like we did in the first one. 8 times 4 is 32. 1 times 3 is 3. 32 over 3. Same deal with this one. Rewrite the 6 as 6 over 1. That gives us 24 over 3, or 8. Next up, now we're adding, so we do need a common denominator. So that common denominator will be 12. It's the least common multiple of 3 and 4. So the first one, you need to multiply this by 4 over 4. Make sure you write it as 4 over 4. I see a lot of people just kind of doing this, like 4 times. That's incorrect. Don't write it like that, because that means I'm just multiplying 4 by 2 and leaving the 3 a 3. So shortcuts like that leads to mistakes. Multiply the second one by 3 over 3. And that's going to give us 8/12 in the first one, plus 3/12, or 11/12. Now 6 divided by 0.5. 0.5 can be written as 1/2. So this is really 6 divided by the fraction 1/2. And if we divide by a fraction, that's the same as multiplying by its reciprocal. The reciprocal of 1/2 is 2, so that's 6 times 2, or 12. Now with 0.3, that can be written as 3/10. So we have 9 divided by 3/10. That's the same as 9 times 10 over 3. Now we can cancel here because we have a common divisor of 3 with 3 and 9. 3 turns into 1, 9 turns into 3. 3 times 10, that's 30, so we have 30 over 1, which is just 30. Next thing we're going to look at is determining if a number is a solution to an equation. So solutions to an equation are those numbers that make the equation true. So if we plug it in, we should get the same number on both sides of this equation. So let's try it out. I'm going to plug in 2 for every instance of x. So we got 8 times 2 minus 10 equals 5. Not really sure if that's true, so I'm going to put a question mark over the equal sign. And we got 16 minus 10 equals 5. Maybe. But then we get 6 on the left and 5 on the right. So those two numbers are not equal to each other. So 2 is not a solution to 8x minus 10 equals 5. Try it out. Your turn number 1. We're going to determine whether the following equations have the given numbers as solutions. First one, 0.1 times x plus 3 equals 0.8. And we're going to plug in 5. Order of operations, do inside the parentheses first. It doesn't really matter because we could do distribution, as we saw in one of the earlier lessons. So I'm going to go ahead and do order of operations. And 0.1 times 8 is 0.8, so we got 0.8 equals 0.8, and that is true. So 5 is a solution. B. We're going to see if 2 is a solution to this equation. So we're plugging in 2 for every instance of x. Right, 6 times 2 is 12. Plus 2 times 5, 14. $22 is not equal 14, so 2 is not a solution. Next up, we're going to plug 12/5 into this one. So 2 times 12/5, that's going to give us 24/5. 3 times 12/5 is 36/5. Now we can add these together. We already have a common denominator. So that's 60/5 plus 8 equals 20. 60/5 is 12. Or 60 divided by 5 is 12. So 12 plus 8 equals 20. And 20 equals 20. So that one works. 12/5 is a solution to that equation. Last up, we're going to see if 5 is a solution to this one. 7/10 times 5 plus 1/2. 7 times 5, that is 35, so we got 35/10. Now we can get a common denominator here, so we go 35/10 plus 5/10 equals 4. That's 40/10. Yes, 5 is the solution to that one. All right, next up, we're going to figure out how to solve equations. So equations that have the same solution, they're called equivalent equations. And we're going to learn some moves we can make that create equivalent equations. So that means when we make these moves, the solution set does not change. So the solution that we get at the end is going to be the same solution as the original equation. And one of the properties we're going to use to make these moves is the addition property of equations. So if we look at these two different equations, a equals b and a plus c equals b plus c, those are equivalent equations. And what this means is we can add or subtract, subtraction works as well, the same number to both sides of the equation, and it does not change the solution. So think of equations as being a balance. If we're given an equation, we know that these two things are equal to each other. So if I put A here and B here, think of them as the values being like a weight. And so they have the same weight when we put them on the scale. And so the scale is balanced. Then if I take C, if I put, let's say, C more pounds on this side, and then C more pounds on that side, well, that equation is still balanced. But if I have some equation like this, where A equals B, and then I go ahead and add A plus C to one side, or if I add C to one side, that equation is no longer balanced. Those two things no longer equal each other. And what's going to happen is this balance is going to shift this way. We need to keep that balance level so that both sides are equal. Here's an example. X minus 7 equals 6. So you're going to look at the number that's next to the variable. The goal in solving equations is to get down to a form where the variable equals a constant. If we get the equation like this, the equation is solved. A constant could be any number. So I need to get this thing by itself. So we're going to look at what's happening to the x. We're subtracting 7 from it. So what we need to do is get rid of that 7 so that the x is by itself. So what we're going to do is add the opposite of this number. That's why we learned about additive inverses. Because we want to get rid of it, we want it to equal 0. So negative 7 plus 7 is 0. What we get over here is x plus 0. And on the other side we get 13. We don't usually write the 0 then, because 0 doesn't change the value, so we're just left with x equals 13. We added the same number to both sides, and it didn't change the solution set. So if I take this, plug it back in here, 13 minus 7 is 6. So that's why we learned how to figure out if a number is a solution, so we can check our work. You should do this on every problem. So take that number, plug it back into the original equation, and see if it makes it true. Your turn, number 2. X plus 2 equals 5. And we still want to do the opposite operation of what's here. So we have addition, so we're going to do subtraction. Minus 2, minus 2. X equals 3. If I take 3, plug it back in here, 3 plus 2 is 5, so it works. Your turn, number 3. Now when we start throwing negatives in here, this is where it becomes really important to check your work. It's very easy to make a mistake with a negative sign. But if we take that value, plug it back in, and see if it works, we can catch those little mistakes. So I'm going to do the opposite of what's here, so plus 4.6 plus 4.6. We get negative 3.7. All right, now I'm going to take this negative 3.7, plug it back in here. Negative 3.7 minus 4.6, that gives us negative 8.3. Your turn, number 4. Now I get some fractions. Now you can do the arithmetic with your calculator. That's not a problem. If you feel confident in working with fractions, you can go ahead and do that as a time saver. But if you're still struggling with fractions, make sure you do all these by hand because it'll be the best prep for what we're going to see later on in the course when we work on rational expressions. You're going to need really strong fraction skills for that. So we'll do the opposite over here. I'm going to add 1/4 to each side. Then we got 2/3 and 1/4. We're going to add those together. So 2/3, it'll give us 8/12. And 1/4 is 3/12. Then we get 11/12. All right, now let's take 11/12, plug it back in here. We get 11/12 minus 1/4 with a 12 denominator, that's 3/12. Equals 2/3 is 8/12. 11 minus 3 is 8, so that checks. Next up, we're going to work on the multiplication property. So we'll need this multiplication property if there's a coefficient other than 1 on the variable. With all of these, we just had a coefficient of 1 on the variable. So only using the addition property is very limiting. We include the multiplication property. Now we'll be able to solve many more equations. So here we've got two equivalent equations, A equals B and AC equals BC. So that means we can take any equation, multiply both sides of the equation by the same number. We've got an equivalent equation, which means we have not changed the solution set. So when we're solving equations, we can always multiply both sides of the equation by the same number. So 7x equals 28. And this works with division as well. So you can either multiply both sides of this by 1/7 to get rid of the 7. Right? We're going to multiply by the inverse, otherwise known as the reciprocal. Or you can divide both sides by 7. Either way is fine. So both of those are acceptable. Now here the 7's cancel. So we get x equals 28 over 7, which is 4. Now to check, I'm going to take the 4, plug it back in here. 7 times 4 is 28, so that works. Your turn, number 5. So we got a coefficient of 3, so we'll divide out the coefficient. Both sides by 3 and we get x equals 7. 3 times 7 is 21, so that checks. Well, sometimes we'll have negative coefficients. Make sure you include that negative when you divide. And this will change the sign of the number on the other side. So 30 divided by -5 will be -6. X equals -6. Now if I take -5, multiply by -6, negative times a negative is positive, so we get positive 30, and that checks. Next up, your turn, number 6. negative 12x equals 60. Divide by the coefficient on the x. And we get x equals negative 5. Plugging it back in, negative 12 times negative 5 is positive 60. Now sometimes we'll get a fractional answer. For the next one, we've got negative 8x equals 20. So we'll divide by the coefficient of negative 8. Negative 8's cancel, and we got x equals negative 20 over 8. But this isn't in lowest terms, because we have a common factor of 4 in 8 and 12, or 8 and 20. So if we divide top and bottom by 4, you get negative 5 halves. All right, now I'm going to check. So we got negative 8 times negative 5 halves. Negative times negative is a positive, so those cancel. 8 times 5 is 40, so we got 40 over 20 equals 20, and 20 equals 20. So that checks, and that is our solution. Your turn, number 7. Dividing by the coefficient on the x, it's 28 on both sides, so that gives us x equals 6/28. And both of those are even, so now we can divide by 2. And that gives us x equals 3/14. Next up, we've got an equation with a fractional coefficient. One way of writing this is x over 3 equals negative 2, or it may be written as 1/3 x equals negative 2. You may see it either way. They mean the same thing. All right, so we're going to clear these fractions, or this fraction, by multiplying, the entire equation by 3. That way we've got, on the left-hand side, we have 3x over 3 equals negative 2 times 3 is negative 6. The 3's cancel. X equals negative 6. So if I take negative 6 and plug it in here, negative 6 divided by 3 is negative 2. Your turn, number 8. So x over 5 equals 4. So, like clearing fractions, same deal is to multiply both sides by the 5. And that way 5 on top, 5 on the bottom cancel, and we're left with x equals 20. Now we're going to look at a few with a denominator other than 1. So let's look at two different methods of solving this equation. So the first method involves clearing the fraction. So I'm going to get rid of that fraction. So I'm going to multiply by the denominator. So we're multiplying that whole equation by 3. So we'll distribute 3 into here. So you got two different terms, one on this side, one on this side. So we'll go 3 times 8 on this side. We get 24, and then 3 times 2/3, the 3's cancel. We have 2x. Divide both sides by 2. And x equals 12. We can also, as method 2, multiply by the reciprocal of the fractional coefficient. Reciprocal is that fraction flipped over, so we're going to multiply by 3/2. Remember to multiply both sides by 3/2. Well, the biggest mistakes I see is people doing operations only to one side of the equation, throwing that balance off. All right, now look what happens here. We have a 3 on top, 3 on the bottom, those cancel. 2 on top, 2 on the bottom, those cancel, leaving just a 1 over here, or 1x. Remember, when we cancel, we don't get 0, we get a 1. Over here, 8 times 3 is 24, divided by 2 is 12. So same answer either way. Use whichever method you like. But I'd like you to practice them both. So let's do your turn number 9 using both methods. But on homework, just pick one, whichever one you like. On this side, we'll clear fractions. We're multiplied by the denominator. So it's multiplying everything by 5. On the left-hand side, the 5's cancel, leaving just 4x. And on the right side, we got 5 times 40, which is 200. Divide both sides by 4. And x equals 50. This one, I'm going to multiply by the reciprocal of the coefficient. So flip that fraction over to be 5/4. 5's cancel, the 4's cancel, that's gone. So whenever we multiply by the reciprocal, that just turns into 1. So we got 1x on the left. Now we got 40 times 5, which is 200, divided by 4, which is 50. X equals 50. Our next equation, we've got a coefficient. It's a little deceptive here. It looks like a minus sign, but that is actually a -1 coefficient. So to get rid of that, we'll just divide both sides by -1. Negative divided by negative is positive, so that cancels out. So x equals -12. Your turn, number 11. We got -x equals -8. Divide both sides by -1. Those negatives cancel. Those negatives cancel, and we get +8. Next up, we've got a fractional coefficient that's negative. So we're multiplying by the reciprocal. Make sure you make that thing negative. So we want the negatives to cancel too, not just the fractions. So over here, we're going to multiply by -5/2. All right, negatives cancel, 2's cancel, 5's cancel, everything's gone except the x on the left. On the right, we got 12 divided by 2 is 6, times 5 is 30. So we got -30 for our answer. Over here, take the number, divide by the bottom, multiply by the top. Sometimes it's easier to divide first, because then you get smaller numbers. So we get a 6, 6 times 5. Your turn, number 12. Negative 3/7 x equals 6. Multiplied by the reciprocal, negative 7/3. Negative 7/3. All right, 7's cancel, 3's cancel, negatives cancel, everything's gone. Over on the right, I'm going to do the division first. 6 divided by 3 is 2, times 7 is 14. So we get negative 14. Now some equations, we won't just have a single x term. We may have more than one. First step in solving an equation like this is always to combine like terms. We need to simplify one side of the equation if possible. So 3 and 5 is 8, so we get 8x on the left equals 32. Then divide by 8, x equals 4. Let's make sure that works. 3 times 4 is 12, 5 times 4 is 20, 12 plus 20 is 32. So that checks. Your turn, number 13. Let's combine these x terms, the like terms, because the variable parts are exactly the same. Both have x's. Negative 4 plus 9 is 5, so we get 5x equals 35. Divide by 5, we get x equals 7. Let's make sure this is right. Plug in here, and let's write this one out. Negative 4 times 7 plus 9 times 7. Let's see what we get here. We got negative 28, and this is 63. Add these together, and we get 35. Next example, we got 6x minus 13x equals 56. So sometimes when we combine like terms, we're going to get a negative, then we can use the techniques we saw earlier, getting rid of negative coefficients. 6 minus 13 is negative 7. Negative 7x equals 56. Divided by negative 7. We've got x equals positive divided by negative is negative. Don't lose your negatives. So x equals negative 8. Your turn, number 14. Negative 15x plus 12x equals negative 27. So we'll combine these two. Get negative 3x on the left. We'll divide by negative 3. Now we've got a negative divided by negative. That'll be positive, so x equals 9. So that's it for today. Next time we're going to work on equations where we use both of these properties within the same equation.